Be sure to watch that.
Oh, yeah.
All right. I think we're ready to go. Greg, do I have to make you something for you to
Yeah, you got to set it for me to share screen. It's probably under participants or
I can click it to see if it works here.
it's
out to
either there. Let me see if I can share screen. Does it give me authority? Actually, I think I can.
Okay, well, try it. If you can't, I'll.
Yeah, I'm seeing Greg Allison. Yep.
All
That's
right.
it.
Okay, so Greg's gonna give us the lowdown on the details on what he did to produce the little summary report that we had based on all the other information that he's gathered. So go ahead.
All right. The good thing about this is it's got all the pictures in it. So we all know the risk of these balloons. Well, hang on. So my point is this: from the altitude of 30 kilometers, you can reach a diameter of your effective range of an EMP of something on the order of 442 miles in radius. And at this altitude, the same device, it could be at 400 kilometers or 30 kilometers. I think you're going to get a lot more intense feel at 30 kilometers. So I think it can really fry things and do a lot of damage. But these balloons are easy to launch. That's what I'm going to show you. And you could really devastate the United States with a balloon attack. So buckle up. This is the idea of showing that if you look at the center of these, this is where the burst would be. You're way offshore at all these centers here. Some of them are out even outside the ADIZ. That's a little bit inside the ADIZ, I think. But this whole idea is this is about the range you would get from something on the order of 30 kilometers. Now, if I were designing a balloon, EMP balloon, I would actually go a little higher. Instead of a little bit under, 98,000 feet, I would probably set it for 120,000 feet to go off, because I can get a balloon up there pretty easily. And it's going to be harder for anybody to put a countermeasure against it and get a little bit more effective range. But this whole idea here, what the operative idea here is that you're going to be offshore with a ship launching this balloon. This is not going to be the super pressure balloon that came over from China, or that could be. Now, those super pressure balloons were designed to be able to carry over a metric ton to 30,000 feet. And it's interesting, they set the design for 30,000 feet because the one we saw was not flying at 30,000 feet, but it was designed to fly at an altitude for where he had slower bands of air. I'll show that later. So it could monitor a little better, do the reconnaissance. Of course, we all know what Dr. Pry told us about 9 out of 10 Americans dying. So I don't need to beat on that. So, okay, guys, the Chinese are already into testing weapons from balloons. This is not new. They are doing it and they're expanding their program. This is a Chinese weapon test balloon right here. And here is the payload. This payload looks a lot like mini DF, it should say DF, not DR, DF-17s. They're like their hypersonic vehicle. But if you look at them, each one of these has got a little different design on them. So they're actually testing flight parameters of different designs. And this is what it really looks like, what they were testing in that mission. And so they're doing a lot of various tests. Now, these are glide vehicles, which you can give them cross range from a balloon, which means you can go further inland than the circles I showed you earlier. And I'll show you other ways to do that too. Of course, we know we got 3 grids. And if you're launching from the West Coast, the further in you get, look, we got Chinese ships going into Port Charleston, guys. They can launch us East Coast, West Coast, or the Gulf of Mexico. They could hit all these grids. So this is the Chinese balloon launch facility, the ground facility in Hainan Island. I took this image from Google Earth. So it is there. There is also, they can launch these things like crazy from their desert sites and other places. This is got the concrete pad, so they got a little crane structure here. They can adjust this whichever way the wind's blowing, which you can easily do on the ground with the balloon, or with a ship. You can always just match the direction of the wind. The ships are actually the easiest way to launch. Now, this is the coverage that we see as a function of altitude. This has been published, I think, Meditech study. 30 kilometers. So this is what we're talking about right here for most of your Chinese balloons, at least that super pressure balloon. You can get a little bit more than that if you go to a zero pressure balloon. And this is what you would expect from orbit. And so this is kind of gradations in between balloon and orbit. So just to give you an idea, but it's the same device that does this. If you put all of its force down here, I think it's going to put out more volts per meter on the power lines than up here. So you tell me. This is the kind of ranges you get. So this is the formula. This is an RF, basically, you know, to the horizon kind of a formula here. So the RF range in miles for the radius is 1.41 times the square of the H, which is height in feet. So you can work this out, and you can just plug these numbers in and for different altitudes and come up with what the radius is. Now you double this for the total coverage diameter. So for a typical zero pressure balloon, 120,000 feet is an ideal target.
Hey,
Because-
Greg,
yeah.
what's a zero pressure balloon?
Okay. The balloon that flew over, I'll show you some pictures toward the end of this. The balloon that flew, I think I still got them in here. The balloon that flew over as a spy balloon was a super pressure balloon. It keeps the same shape. They've got what they call ballonets in it, where they can change air ballast, basically. I'll show you that in a little bit. It's always set at the same pressure, and it's got a set altitude. A zero pressure balloon actually vents to the outside. It has the same air pressure on the inside as on the outside, but the air is less dense in it because it's helium, and so it gets buoyancy. So it gets up real high. But it's going to, if it gets over pressurized, it will actually vent gas out the bottom. It has a vent tube. The super pressure balloons are meant to be able to take a bit of a pressure difference. They've made out of stronger fabric or whatever, so they're a heavier balloon. But the zero pressure balloons will go higher. They're cheaper. They're easier to launch, I think. But the one that came over was not a zero pressure balloon. It was a super pressure balloon. The super pressure balloons are better for keeping up over a long period of time. If you want something to stay up for months, then that's the balloon to choose. If you just got a quick mission, I would go with a zero pressure balloon. If I was launching from a ship offshore, I would go with a zero pressure balloon, because the mission's only going to be on the order of 1 to 4 hours, and then boom. All right, that's the Starfish Prime. I'm sure y'all have seen that. All right, again, this is the idea that, you know, you could take in our missile fields, one of these devices with this radius, if you can get the balloon over the right spot.
That corresponds to actually the hemp calculations for E1.
Yeah.
What you just had there.
Yeah, yeah,
Greg. Yeah. So sorry to interrupt.
yeah. This corresponds, and well, you know, the RF. Oh shoot, it's going away with me. What's happening here?
Oh,
Yikes! I don't want to do that. It got away from me here. Hang on, guys. It went spastic on me. All right, let me do a. Oh, what I hit to cause it to do that. Anyway, let's go back down. Yeah, so, you know, I've got that equation that I'm using. It's very similar. It gives you about the same stuff that Meditech gives you. Very close, very close. This is basically what you can see to the horizon from an altitude with RF. And, you know, this close, this shows, you know, like the one I showed you a minute ago. If you detonate it outside the United States, you know, this is how the Chinese balloon that came over us last time came in. You know, it went like from there, and then it actually went up to there. You know, it went down. It was over that area right there. That balloon was. So, but you can still be outside the United States, although we do, you know, fly our jets over Canada. Like we shot down a party balloon somewhere over the Yukon. I'm convinced that was a party balloon. I think it belonged on that North Illinois group that I'm familiar with up there. All right, guys, this is a balloon launch I did from a ship in 1998. That was June the 20th, 1998, and you could have fried an egg on that deck in the Gulf of Mexico. But this is showing that you can do a freestanding inflation. You don't have to hold it down. You don't need a crane to handle it, to hold it in case of winds. What you do is you run the boat. Now, we were actually on a barge that's been pulled by a tugboat. But if you can run it and keep it in the same speed and direction as the wind, you can inflate that balloon straight up. And then when you're ready to release it, you just let it go. So this is our, this was a club project. This was done for next to nothing, guys. This was actually a project of a club. We spun a company off of this and did more of these later. In fact, we did a mission just 3 months after this one. 3 months later, we were flying a wing body with the company I spun off in a phase 1 SBR, which is typically a paper study. So, guys, this stuff.
Greg, that balloon you've got there, that picture you had.
Yeah.
Is
That's
that like the size of a weather balloon? How much can that thing lift?
This thing here, the payload for this was a couple of 100 pounds.
Oh,
It would easily take 300 pounds. That was probably about 250,000 cubic foot balloon. The gas bubble is up here. When this thing gets up to 100,000 feet, that will fill all this out. All this will open up and will be totally filled out and spherical. So you got a lot of trailing plastic here that fills out. That little bitty bubble of gas will expand and fill the whole thing up. So I'll show you our Heart Cat's Prize balloon. Now it was a little bit bigger balloon than this because we had over 300 pounds on that one. This is the rocket. This is the Halo SL2 rocket. When you launch a rocket from balloon, it's known as a rockoon. This is 20 June 1998, almost 25 years ago. I was doing this when I was a kid. I headed that up. That was my project. I come up with the idea and we did it. Now this again is showing you what you could do just from the balloon offshore. How do I think? Showing that from a ship, it's easy to reach these targets with balloons. You can put it one ship off the West Coast, one or two ships off the West Coast, a couple of ships off the East Coast, and a couple down here in the Gulf, and you could be putting up a balloon every hour, and you just have a train of these before anybody would know it. The crazy thing is, when you look at a horizon, if you're over here in shore and you're looking out here to the ADIZ, which is 400 miles off. If you're out here at 400 miles, when you launch this thing, that balloon is going to be at 80,000 feet before it's ever detected. They ain't even, they couldn't see it. If they could see it, they can't see it because it's over the horizon until it gets to 80,000 feet. And then a lot of the radars are really spec'd at 250 nautical miles. And that's for a good target. I can make this thing almost invisible to radar. So I don't think they'll see it. I could probably fly it right, get it dead center right here and set it off, or even right here and take out all this stuff. We'll go over that in a minute. Here's the theory. You're out here in a barge, you launch it, floats up, you get over target or out from target. If you think they're going to shoot you down, you could do it out here. Or if you think they're not going to see, you can let it float rover, or you can design it such that it goes off when they shoot it down. That's what I'd do. This is the idea of the winds are very different at different altitudes. So what you get, in fact, you got a dead zone in here at about altitude of where they were flying the spy balloon. The winds are a lot lower, and that's why they flew at that, because they wanted to have loiter time overhead. But you get up here to over 30 kilometers, and the winds really pick up. It's even higher than the jet stream. Typical jet stream. This is your jet stream down here. So they were over the typical jet stream, but not up here. So you got a jet stream that's pretty good. Here it's slow, and up here you're fast again. So fastest winds maybe up to 200 miles an hour ground speed once you get up to 110, 100,000 feet. So you can cover a lot of distance in a short time. But to slower end, it might be 40 miles an hour. But they could get overhead in a hurry at that altitude. And so you got periods, what's called, fastest in January to March and mostly out of the West, but you got a turnaround period where you can just launch this balloon straight up and loiter, basically. Also, it's in the spring and fall. And then you got a period in the summertime when the winds at that altitude run from west to east. So if you're on the East Coast, the balloon would easily drift over the United States. So if you wanted to maximize East Coast attacks without using some assist device, like a glider or a rocket, then that's when you would do it. If you wanted to launch over the West Coast,
Hey, Greg, and that first bullet on the last slide, at 110 to 130,000 square feet, what size payload would you have?
So again?
At 110 to 130,000 feet, what size payload could you have?
I could put 4 tons up there.
Oh, gosh.
4 tons. 4 tons. The balloon would be pretty big, but I could put a 4-ton plane, way more than I need. Hey, give me 150 pounds, I can do the job. But I could put 4 tons. I could put multiple HEMP devices on rockets. I could have a 6-shooter of rockets, each one with a HEMP device on it, easily.
Wouldn't the 200-mile-an-hour winds rip the balloon to shreds or?
No, they flying out all the time because they move with the wind.
Okay.
They're still, I mean, if they were held by something else, yeah, but they're actually part of the wind. They're moving with it.
Okay.
No, we fly balloons in all the time. It does not hurt them because they have no resistance. And if something was trying to hold it, it would be an issue. But they float up into the wind and they just go with it. So it's not an issue. This happens all the time. So you got 200-mile-an-hour wind, it's not a problem because you're with the wind. Not a problem. We ready for next slide?
Yeah.
Yes, sir.
All right. So yeah, what this is saying is how the stratospheric winds turn around. Like I said, they go from the east to they go back over from the East Coast. If you want to launch over the United States, you do it in the summer. If you want to balloon, it would just go straight up and over the same spot. You would launch it and turn around in the spring and fall. If you want to go from west to east, you launch from the West Coast. But you can have assist devices like rockets or glide vehicles that would take you against the wind. And you could get a pretty good penetration into the United States with those devices. And I'll show you, that's what I used to launch 25 years ago. So also you can adjust your altitude by floating up and down, or you catch a different wind and go to a different direction. So, you know, by dropping ballast and things like that. So, but basically, like I said, the lower winds are right there where, you know, the 50 to 60,000 feet level where the Chinese spy balloon was. And they did that on purpose so they could spend more time over target. That's your Chinese spy balloon right there. And here, see, it's got like a balloon inside the balloon. They call this a ballonnet. So this one, inner balloon, has the helium, and this one would have air in it. So they could pump air in and out to increase the weight of it, change the pressure structure. So this was a dynamic envelope type situation. It's far more complex than the zero pressure balloons that I fly, but they claim that they can launch thousands of these. At least their sources claim the Chinese have set up an entire balloon force similar to the rocket force. They can literally launch thousands of these on the United States if they so choose. But you know, I would say that if I wanted to do an EMP attack, I wouldn't try to fly something across the Pacific Ocean. I'd just be launching from a ship because it's easier to launch from ships. And they got tons of cargo ships at sea already anyway. So you know, you wouldn't know it's coming. But this is the Chinese device. That's it. And like I said, I was going to show you a picture of it. So that was it. All right, guys. Now, if you're using glide vehicles or other things to get some interior penetration into the United States, or a rocket or something, you know, if you got a little, you know, 3 points of interior penetration beyond your coastal reach, look, you get most everything. The threat to America could be huge. I mean, this has got the Southern Missile Field plus Cheyenne Mountain. This is the ADIZ. I would say they could station the boats right out here, inflate the balloons before. If your ground radar were good enough, and there's a lot of them respect it like 250 miles to see an aircraft. I'm thinking this thing, if it was right in front of the radar, you almost wouldn't see it if you do it right. But by the time you get to the horizon, you're at 80,000 feet out here. They ain't going to get to you. You're out of their reach by the time they could at best possibly theoretically see you if they had the range, and if they could see a device as wimpsy, or whatever you call it, is what I'm going to talk about here in a minute. So yeah, you can inflict major damage by launching balloons. It's actually smaller down here for some reasons. It goes way out. Well, I guess LA wants to be protected. They got a long ADIZ. How come we don't in my area? It's not fair. So there you are, guys. This is the Hark Catch Prize balloon project. This thing was designed to be able to get over 100 kilometers, and it was this rocket. We did this project this was a corporate project. When we did this, we paid people working. It cost 100. That and renting a boat and buying a balloon and all that cost me about $150,000 25 years ago. Let's just show, you know, this, you know, how much does the AIM-9 missile cost? So, and I got a motor, one of these motor fuel grains beside me. This is an asphalt motor, solid fuel grain with a nitrous oxide oxidizer tank. This was the daddy of the Spaceship One and the Spaceship Two that Virgin Galactic is using today. So this can be done easily on a shoestring budget. This was done in 2000. We're out 200 miles out in the Gulf of Mexico. That's what it looks like. We were using a utility boat known as the Mr. Offshore. And there it is going up. And that balloon will expand enormously at altitude. And all right, this is the avionics. We developed our own avionics. We didn't have cell phones and all the gadgetry we have these days. This is 25 years ago. We come up with avionics that defeated the COCOM limits of GPS so we could track our rocket, and how we weren't supposed to be able to do it. How we thought nation states, you know, in the United States, thought nation states couldn't defeat their COCOM limits. We did that as a tiny little company working out of 2 garages on a shoestring budget. This was our launch system here. This is our launch avionics. We had it encoded too, so somebody else could material launch a rocket.
Pardon me, before you go on, what's a COCOM?
COCOM limits were 2 limits that were set into the GPS to inhibit it from being able to report if it was over a certain altitude and going to be on a certain velocity, with the whole purpose to be to keep it from being used for a missile attack. So they built 2 limits into the system. You could get a waiver on one, but not both for your receivers. So this was to limit what you could process in terms of GPS signal data. We figured out a way to, we got the waiver on one and we figured out how to defeat the other, basically using a 1 pulse per second oven controlled oscillator to give us a steady 1 pulse per second system signal. And we triangulated, actually quad angled it with ground stations. And we built up 4 ground stations. All this was under this budget. This was our avionics that went up in the balloon. We got these Bella switches in it, so it would not be capable of making contact to launch the motor until it reached a certain altitude. These Bella switches were set to expand to make the contact at like 50,000 feet, some set altitude. I forgot, I think we set it about 50,000 feet. And so we were using all mill standard grade connectors, boxes, because we didn't want EMI issues. So this is all very professionally built. And here's one of 4 ground stations we built in this project. So we built 4 ground stations, the uplink avionics, the rocket, the avionics that's on the rocket. We paid for the ship, we paid for the balloon, we paid for the helium and the labor to do all this. And we did it out of 2 garages. This is how now, if we could do this, it's a small little tiny group, and most of us were working part-time on the side. I had a day job. I think I had 1 guy working for me full-time, maybe 2 guys working on this full-time, Tim Pickens, but I had a day job. This is actually just working on the SL2 rocket. This guy here just passed away. We're going to have a funeral for him tomorrow. He's long past, but anyway, so this is the kind of stuff that can be done. Small groups. Now that rocket would have had the 100-kilometer ring. If you had an EMP device on it, if you put an EMP device that can reach 100 kilometers, you got this ring right here. 3 of these would cover the entire United States. Look at that. So you can launch one from the Gulf, one from, oh yeah, I had a range of like 600 miles. You can launch one from the West Coast, one from the East Coast. That's what you could do, 3 of them with a rocket. So just a little rocket assist could buy you a lot of coverage. That's another Meditech study. That's Tim Pickens. This is our balloon launch return vehicle. We launched this thing 3 months after that first picture of the balloon I showed you. Same year, 1998. This one was launched in the fall. So this thing's got aero surfaces on it. It's got a pitot tube, a camera in here, the avionics are here. This is the rocket motor that slid up inside of here. And this is the control box. This is a cold gas reaction control system. This is a launch rail.
Greg?
Yeah.
That return vehicle, what was it returning?
It was built to be capable to come back. So the whole idea was just to be able to fly experiments. This was an experimental vehicle. This is a paper study, by the way. We did this in the phase 1 SBR, which is supposed to be just a paper study. We did several rocket motor test firings on a rocket motor test stand. We flew a subscale version of this, and we built this in Kentucky to sea. This is how I did paper studies. And that's that little blonde hair right there, a lot shorter than it is today. That's me right there. And that's our balloon launch return vehicle going up on a balloon. And so we can just launch it like a butterfly. That's Steve Mistakis just passed away. This is the chief engineer for Raven, Mike Smith. I just texted him today. Aerostar, well, it's Aerostar now. They're the company that makes these balloons. And this guy right here is one of 3 individuals. This is Glenn May. He died in the Spaceship Two cold flow test in Mojave Desert. It was developing Spaceship Two motor using our technology, of course. So yeah, he died doing that. So yeah, 2 of these guys in this picture are dead. That was 25 years ago. We did that almost. There's the balloon on ascent. And that will expand a whole lot more at altitude. So this is my own little cross range type vehicle. I mean, these can be done. And we did this on a low budget. You know, the phase 1 SBR was $70,000. This is our subscale test where we launched it with a rocket. For that, we launched it with bungee cords. So once you launch a balloon, they've got plenty of these cargo container launchers. They could pop out rockets if they so choose. China's got one that's got 2 40-foot cargo containers welded together. It's got an 80-foot rocket that fits in it. It's capable of going to orbit from a cargo ship, practically. You know, that could really reach the United States easily. So there's all kind of mayhem that can be done from ships at sea off our shore. And if you use that missile, you could probably get it up to the 400 kilometer, or from a satellite, or from any other ICBM. This shows the idea, you know, Dr. Pry taught us a long time ago that attacks upon the United States will be a multi-pronged attack, probably with hacking, kinetic attacks at ground stations like the Metcalf station, you know, and you could have all kind of balloon-based EMP attacks. And a sufficient balloon, you could actually launch a rocket. With a 4-tonner, you could build a rocket that would reach this altitude, even from a balloon. So this is all balloon capable. What you could do that could, you know, you could just have all these overlapping and highly concentrated fields. So, you know, the thing is, usually that bigger field circle you see, the field strength's a little bit down on the outside. It's still probably over what a lot of these facilities would take. But by launching over the East Coast and West Coast and the Gulf, you could hit all these military facilities out there with a very intense field. And you could probably get the balloon much further inland before you set it off if you so choose. So, all right, so I just made an example. You know, actually I should have took the warhead from a cruise missile, but this made it you know, a little more interesting. This is the W-87, which a lot of you are probably already familiar with. And that's showing it next to a person. This is 1986. So my whole idea is, you know, let's put this in a package I can sling underneath the balloon. This is the real operative part right here, not all that, you know. We don't need the D-spin, spin controls and all that stuff because we're not doing that. So if you want to hide it, I've had people say, oh, well, we'll detect the radiation. If I put it in a bucket of sand, there's going to be very little radiation coming out. This is the idea of how much attenuation you get with 18 inches of packed rammed earth. Well, sand's actually denser than packed earth. So, you know, I checked out the densities. I've ran all those numbers. So you can stop most of the gamma rays, and it would be very difficult to detect if you could get close enough to detect it. And you're not. Inverse square law also is going to play a good effect for hiding your device, because the density of the gamma rays will drop off very fast at altitude. And you're going to be way up there on the balloon. So here's the idea. You got a barrel, fill it full of sand. You could have a sand release valve on the bottom that you can use as a ballast dump if you so choose. And even the bucket itself could be dropped all at once. That's probably what I did. I probably just dropped the bucket when I detonated it. The balloon will shoot up at that point when you drop all that weight. If you got an accelerometer in here, it can be all triggered to go off on an accelerometer. Matter of fact, what I would probably do is have a timer to cut down what's holding the bucket up, or the barrel. You know, it might be as simple as the kind of timer you just turn with a spring, like that's on your washer or dryer, and it just clicks around forever how long. And when it gets to the designated time, it sends a signal to fire a cut down, a line cutter, like a reefing cutter on a parachute, which a lot of you guys are familiar with. There's bigger line cutters than that, wire cutters and such. Ordnance devices I've flown, you know, they're typically used in the balloon world. So and this drops, that shoots up. The accelerometer is the trigger, and it goes off. and it don't have all this shielding around it, so it maximizes gamma rays. Or you could draw, there's several ways to set this off. You could command it, or you could have an AND gate. Maybe the easiest thing to do is if you want to command it directly, or have a backup for if it gets shot, if you shoot the balloon down, it'll go off automatically if it's got an accelerometer trigger. But you could have a NAND gate so that you've got as long as you got a signal going to it from RF system, it won't go off. And you let your signal off, it could go off. Well, you'd want to put a NOT input into an AND gate to do that with the RF signal being on the NOT input. All right, I'm getting detailed here. You probably don't want to hear all that. But the whole point is there's a lot of design options to make this thing hard to see and easy to go off. So an EMP, if you want to EMP this device, it ain't gonna make any difference if I got a wind up if I got a wind up timer on it, and it's not going to use much power. But I drew this thing like it had solar cells and all kind of stuff, just like the other balloon. But if you just got a wind up timer, you don't need any of this stuff here, which would be better if you don't want it to be seen by radar, not to have all this. But if you want to be able to signal to it, I've shown in here what the avionics could be that you can send a signal. So I've spec'd that out here. So yeah, so I said here that EMP proof device would just have a wind up timer to initiate the package cut down and have a simple accelerometer to ignite the EMP device. So then if you shoot it down, it just goes off. So the whole point would be you want to shoot it down really early in the flight. It means you got to detect it early in the flight. The only way you're going to do that is if you got ships at sea that are watching for this. And I think that's what we're going to have to do. So let's see here. Here's a device you could put on a Raspberry Pi with a software-defined radio, phased array, pinpoint RF source position. You could use an Iridium satellite modem. So you could easily come up with electronics if you want to command it. If you want to be electronics commandable, that system would run you maybe 30 pounds. So this is a total design, and this is a very sophisticated, probably more than I would go into, with a solar arrays, a little truss structure. This is where your balloon tie-off is. This is your avionics box and antennas. These are your line cutters to initiate cutting the whole thing down. It shows an initiator coming from the avionics box itself. A sand release. I got my wire here running around here to command this valve. So a W87 warhead, which I think that's a 300 kiloton warhead. So this shows the whole flight train here with not to scale, because the balloon would be much larger. So it's not at all to scale. Your solar arrays can be very, very far. So if you want to reduce radar reflectivity, there's a lot of things you could do. You could put some stealth technology on that barrel, for example, just by painting it with a polyurethane foam with carbon black in it, and maybe some iron oxide particles that absorb the radar waves. And you can make it, of course, China already has sophisticated radar absorptive materials. They call them RAM, like United States does. But if you just want to have a poor man's, if some terrorist group wants to do this, I mean, they could do this. I mean, you can look at stuff on the internet. This is not, I got that off the internet. So yeah, like I said, China would use a radar absorptive material. You could use a smaller device, like I said, I probably would choose something if you had it available, like a cruise missile warhead. But you could use this backpack nuclear device like they had back in decades ago, the W54. But what we don't want to see is another sidewinder used on one of these balloons. This is what they shot down over the Yukon Territory, by the way. And this is a picosat balloon, and one of my close friends, in fact, I saw him today, sells these little avionics packages for these balloons. He's one of the leaders in this balloon technology. His name is Bill Brown. Whoa, this thing ran away on me again. I don't know what's going on in this presentation. And it shot me right back to the top. Hang on.
That's PowerPoint does that. It has its own mind sometimes, and it just accelerates.
I see that. Let's get back to where we were at.
So Greg, you said that one trigger for the device could be if the connection to the balloon were cut and it started free falling, it would trigger.
You can have an accelerometer trigger.
Right. the balloon that was shot down over off South Carolina, I want to say that was 150 miles offshore. I don't know if anybody remembers exactly, but would that have caused, any major issues if that had a hemp device on it?
If it had, well, it was pretty low when they got it. That wasn't designed to be an MP mission. I don't think you'd want to fly an MP mission at that altitude for many reasons. One of which it's easy to shoot down because you're within the range of aircraft and their missiles. Now, an AIM-9 might have a published range of 20 miles and fire from an aircraft at high altitude and going horizontal. Yeah, but going straight up, no, because it only has a burn time of, like, depending on which version you got, like 5.4 to 6 seconds. It's not going to go 20 miles high. You might get 2 miles high, maybe 10,000 feet. That's all it's going to go. And your 20 millimeter cannon you get on a lot of aircraft, those 20 millimeter rounds aren't going to get any higher than 2 miles either. If you'll be lucky to get them 2 miles up. So anything that's over 2 miles over the altitude of your aircraft, you're probably going to have a very hard time taking down. But also the AIM-9 has a heat seeker on it. I could just put a little dry ice on top of this barrel and it ain't going to be hot at all. The balloon might heat up a little bit in the sunlight if you launch it in the daytime. I would actually probably launch one if I was inclined to do this kind of operation. I would launch it either midday, so you wouldn't get the reflective sun, when it's coming up off of it or when it's going down. Because if you're seeing the reflected sun from a rising sun or a setting sun, if you're on the side where the sunlight's reflecting, it's going to shine like a star. If you're on the other side, where it's been backlit, it'll still light up, but not as bright. If you launch it midday, you're not going to see it. It's going to be extremely hard to see, and even when it's going overhead. If you launch it at midnight, in the middle of the night, of course, you ain't going to see it. You just won't see it at all. So the visual prospects of seeing this thing will be very little. Identifying what it is, it's going to be confusing. If this thing's coming up over the horizon for a radar, if you could have the range with your radar, and I don't think they got the range for 400 miles, you're not going to know what it is. And it's going to be at 80,000 feet when you first see it. So it's going to be already out of your range. Before you can get to it, it'll be out of your range.
Greg, how do you shoot this down if it's at 100,000 feet?
If you let it get to 100,000 feet, you're in a bad spot. You want to take it down as soon as you can. If it's this big and you don't know what it is, you might need another balloon with a rocket on it, or you might need if you're willing to spend the money to fire something like a Aegis missile at it, if it can see it and take it, but you actually need to hit the actual package if you can. And maybe you put a laser on it and heat it up so the heat finder will find it. It may not sit if they're smart to put some dry ice on it. The whole idea of putting dry ice on top of these packages was invented in the 50s. So this is not a new idea that Greg Allison came up with for purposes of presentation. The Man High program that sent people up on these in these big pressurized gondolas, put dry ice on top of them because it'd get too hot inside if they didn't.
But what you said, Greg, goes back to what you said earlier, and that is they could launch hundreds of these.
Yeah, they could. So I don't know that you can afford Aegis missiles. That's the whole thing. I mean, they could literally launch hundreds of these. This is easily done. That's the scary part. So what you really would like to have is some ships out about 200 miles out monitoring for this kind of thing. And if they see it, they act on it fast. That's the best way to do it. Those ships could do double duty for launching communications relay balloons that might fill in the void if we lose satellite comms. So it could be a double duty. I mean, that ship could have 2 or 3 tasks that it's assigned to do, one of which would be to launch from these balloons. But, if we have a satellite warfare going on, you're going to lose comms. You've got to be able to get those EAMs and all that other stuff out to the submarines at sea. How are you going to do it if our comms are down? Well, you might do it if you've got an alternate communications high altitude platform like a balloon to launch. In that case, you might even want to launch a super pressure balloon. But you need to get something up there, and probably if you just got to get it quick at a zero pressure, it'd be good enough. It can stay up there all day. If you design it right, maybe 2 or 3 days. Whereas a super pressure balloon can stay up for months. But you can keep a zero pressure balloon up for maybe 3 days, 2 or 3. So they'll lose altitude after a night cycle. But you could launch, if you launch it at night, you know, you can fill it with enough helium, it's going to go to full altitude initially. So we don't want to shoot these things down. So we need some rules for what is a valid target. And basically, I thought, well, we may have the total payload package. I think I kind of looked through what was reasonable. I thought, you know, the way the balloon counts itself, including the weight of the helium, everything you put in, it's part of the total weight of what it is. So that guides how much, what size the balloon's got to be. So I think a total system with balloon, payload, helium, everything, about 150 pounds. You know, when you look, it takes at sea level, it takes 1.1 ounce with a cubic foot of helium. So you can figure out how much helium it takes to lift 150 pounds, 2,640 cubic feet. But then you got to factor in at the altitude of 300 kilometers, you're 10% of the 30 kilometers, you're 10% of your atmospheric pressure. So you want to set, well, that's actually 53,000. That's the spy balloon. It's under 30 kilometers. So that's 10% of the sea level atmospheric density. So you got to be 10 times bigger. To go to 100,000 feet or over 30 kilometers, you're going to be in 1% atmosphere. So your balloon's got to be 100 times bigger than this. So that's what I show. And it's basically the smallest balloon I think you're going to see at lower altitude and higher altitude is like 40 to 80 feet. And if somebody can't mentally fathom that, we can say 1 to 2 buses for those. And for some reason, that's how they describe the Chinese spy balloon. So that's why I came up with start calling it in reference to buses. I got a bus out here in front of my house, by the way. So, but they were shooting at stuff the size of a car. So I said, nothing as small as a car should be targeted. There's a lot of legitimate scientific balloons flying. So especially, and some of them are bigger balloons, but you should, the biggest ones, you ought to know whose they are. I mean, they've got already reporting requirements, guys. So that's the operative thing. And I went through here and I calculated the diameters, the lift, and all this stuff. And so the bottom line is you shouldn't be shooting down any balloon smaller than this. And hopefully the other balloons, yeah, we were shooting at party balloons, car size balloon over Alaska, just all kind of craziness. And just burning AIM-9s for nothing. Those balloons were a threat.
Kabuki theater.
Exactly, Kabuki theater. It was all just that. Those balloons were not a threat. We were wasting money shooting those things, and probably shooting down legitimate objects. I don't know. I think the one that they shot down over the Great Lakes was probably a escaped Chinese lantern or something. What they described, strings hanging down. Anyway. There is a history of balloons being used in warfare. The Japanese launched these Fugo balloons back in 1945. They intended to cause the fires on the West Coast. One of them actually killed a woman and some of her kids. We developed a munition drop system for a balloon that would drop canisters. That this was called the E-77 balloon. We were doing this stuff back in the 50s. The whole idea it was to drop wheat rust to try to infect crops. This was that package put together, excuse me. So that's when it opens up. That's what it looks like all assembled. And we even played around with some gliders for the same purpose. Now, of course, this was, you know, before we had the sophisticated UAVs of the day, but this was adequate. And this little glider would actually had a section that pop open, kind of did a shuttle concept, kind of like the spaceship 1 and 2 Burt Rutan concept. So this thing had a way of gliding in. This is a small thing, you know, this is 6 inches, you know, here maybe. So this whole thing wasn't more than much over a foot across either way here. The Chinese now have come up with a very sophisticated little glider, and this is actually built on a PC board for the wings. So that's kind of crazy, but I guess it's cheap, and then we'll get lift once they fall into the atmosphere. When it's deep enough, this whole thing was designed to be dropped from a balloon in a drone swarm. So they have plans of, and look here, so they got a little actuator here, and they got little Evelons out here just to be able to give this thing actual control authority in flight. So it's not just a glider, it's just going to drop wherever it goes. It's got guidance. Onboard guidance, and it's got a GPS module in it to help affect that onboard guidance. It's crazy, guys. And And so here's the scenario. They fly this thing up and they drop these things, just a bunch of them, wherever they want to drop them. And then here's some pictures from where they were testing this stuff.
Is that a super balloon or is that a zero, I'm not sure what
Zero
you call
pressure. Well, you could do either way. Now, this picture from the looks of it, that looks like a super pressure balloon. So super pressure balloons and zero pressure balloons. But that don't mean that if you want to launch it from China and let it float over the United States, you would use a super pressure balloon. If you want to launch it at sea, which is, I don't want anybody to see. If I'm going to do an EMP attack, I don't want anybody to see it coming. Spy balloon, I don't care. If it's an EMP attack, unless you got thousands of them. Now, they could do that. They could do a balloon swarming, and they might do a combination. They might have a bunch of these on their way from China and then have ships at sea launching other balloons. Or we could just have be saturated with balloons all at once and not know where in the world they came from. That's a
the zero pressure goes to 40 kilometers, and the super pressure goes above 100 kilometers, 120 kilometers, correct?
Well, we're getting feet and kilometers mixed up. The design point for their super pressure balloon was to be able to take a metric ton to 30 kilometers.
Okay.
Now you can, with a zero, that's with their super pressure balloon. Now that thing can stay afloat for months, and you can do a lot with a ton. I can do a lot with a few 100 pounds. Now the zero pressure balloons, which are not as sophisticated, they're cheaper, faster. I can launch one of those, and my EMP mission, if I'm launching offshore, is only going to be no more than 3 or 4 hours, depending on how far I want to float in. It might be an hour and a half total mission time. That thing can stay up 2 or 3 days, but I don't need all that. So I don't need if I'm doing a sneak attack from offshore with a zero pressure balloon, you don't need all that. So there's a lot of these zero pressure balloons can get up to about 120,000 feet, which is well over 30 kilometers. So your 30 kilometer point is what, 58,000, something like that. It's just under 60,000.
Okay.
No, it's 98,000, I think, feet. I have to go back and double check, but it's under 100,000 feet. 100,000 feet was usually my set point for most of my balloon missions. Although I did one at 80,000. So.
And the 80,000 feet balloon was a zero pressure balloon.
Everything I flew was a zero pressure balloon. If you look back at those other pictures, those were all zero pressure balloons. They were good enough to do what I needed. I didn't need a super pressure balloon.
So here's my question then. Okay, just because I wanted to ascertain the difference between the two. What is the defense strategy difference between a defense strategy for a high pressure balloon and a defense strategy for a zero pressure balloon? Are they the same, or how do they vary? How does that vary?
Well, if the balloon's at 30 kilometers or above, it's from a defense strategy, it's going to look a lot alike, only you might have warning time if they're flying as a super pressure balloon. You might see it somewhere over the Pacific on its way over, because it's going to be in the sky a lot longer coming to you. The zero pressure balloon could be launched offshore with no warning. You may never see it. I mean, even your radar may never pick it up at all, even if it's in front of them. If it does, the thing could be at 80,000 feet before you would even start scratching your head asking, what is this? The time you try to scramble any fighter jets out there, it's going to be out of the range. So the defense strategy for these balloons needs to be that we've got something offshore monitoring for them, be able to take them down when they go up. Would we have enough AIM-9s? Probably not. We might need a balloon to fight balloons with. If you might need to be able to send a balloon up with a 12-pack of multiple rocket launcher type system to launch a bunch of raccoons after these things. But you'd want to shoot to the payload, not the balloon, because if an AIM-9 just went right through the balloon envelope, it'd be like opening the doors on a warehouse. Unless even if it blew up inside, it might not do enough damage. Even though they do have some overpressure and some shrapnel, but it would be likely just to fly straight through it. And you could sit there and if you could get a gun within range, you could shoot that balloon all day long and just making holes in it. You're just like opening little doors or little windows in a warehouse. It's not going to come down anytime soon unless you find something to really rip a big hole in it. I would aim for the package, because also, like I said, if that package has got an accelerometer on it, just shooting at the balloon, if you should be lucky enough to take the balloon down, the whole thing is going to drop and would set off.
Okay, I get that. Now, that's if you're up there, and you're aiming the gun or aiming the weapon that takes it down, or whether it's a rocket or a laser or
The further offshore you get this, the better off you are. The lower altitude you take it out, the better off you are. If you could take
But
this,
what detects it though? I mean, how do you use the AI to determine where to shoot the package? How do you identify the package as the object, as the target?
package would hang below the balloon, just like you
And
see.
what-
You see
and what-
this picture here?
And
That
what
little
is it?
dot, that would be the package. You need to be looking for something hanging underneath the balloon. That's what happens.
Okay,
So that's the whole objective, because this is what's going to cause all the problems.
okay,
It's going to be hard to take out. It might be easy to hit, but it's hard to take out.
okay. So dimensional, it's a dimensional definition then. Whatever is hanging below the package is a package below the balloon is
Right.
dimensionally where we want to aim.
And you might want to hit it with a laser or something just to heat it up enough that an aim would target it, or an aim or a whatever you can get up there. But I don't think you can get aim. I don't think you can get aim high enough.
Yeah.
So
Yeah.
you'd probably have to shoot it with an Aegis or something if you launch it from the ground.
Yeah.
I would say that if you see something like it going up, if you could put a balloon up, or if we had aerostats off the coast that were moored and would already have some altitude and a missile package on them, they could take this thing out from a higher altitude. At least
What is the range of a directed energy? I mean, because you brought that to me. You raised a good point there. Maybe directed energy is what we need as a defensive weapon for this to, because if you heat everything up, I mean, that's as good as gold, isn't it?
Now you can't get it hot enough. Now, if you fire the laser from the ground, because you're going through 20 miles of atmosphere, that you can get incredible beam spread with that laser, and it may be hard to even heat it up enough for a missile to see it, but you're not going to get enough heat to even cut the plastic up here.
I thought that we had some tests of shooting down some aircraft from a battleship with a laser, but that's not my question.
Yeah, but that's not at these kind of distances. You
Yeah,
get
no, I
spread.
understand.
Problem with lasers is
Here's my question, Greg.
they will bring beam spread on you.
Here's my
Now,
question, Greg,
there is a way.
question.
Yeah, there is a way.
Given the balloon that flew over Alaska, Canada, and the US in the first weekend in February,
Mhm.
which lasted the better part of a week, I think. Was that a mistake not shooting that down early?
Yeah, I think they should have shut it down
Yeah.
as soon as they saw it. Yeah, I would say it was a mistake because they let it get too much reconnaissance, and you gave them the idea that we won't do anything. We should have took it down early on. That one, we knew it was not one of ours. We knew it was Chinese. We knew all that from the get-go with that balloon. But and it didn't have an EMP package on it, fortunately, but it wasn't at that balloon was targetable because it was flying within the range of military aircraft. What I'm telling you is that balloon same balloon could have been set for a different altitude. It could have flown a lot higher. Those balloons are designed to be capable of hitting 30 kilometers. It was not at 30 kilometers. It was at the perfect wind altitude. Well, let me, before I get straight, before I forget it, there is a way to use a laser.
Mhm.
And here's how you do it. You have to be at high altitude where the air is thin. So if you had another high altitude package, like from a balloon, and there was another balloon out here, then you could either fire a laser from that balloon because you're going across only 1% atmosphere, or you might, if you have a laser straight under it, so it won't have to go cross range to fire directly up, you might have a redirect mirror. So if you could get an aerostat up high enough, and I don't know, aerostats are limited, but if you get because of the tether, but if you could get an aerostat up high enough, or have a very high altitude aircraft that's flying a pattern, and then put a laser up straight up to it and then let it redirect it, you could get a lot more range, and then you might get enough heat on the balloon. If you're firing cross range to the atmosphere, you're not going to get it.
Greg,
beam
Greg,
spread.
what about, well, speaking to that point, what about a fleet of low orbit satellites?
If you had they'd take a whole lot of them, and give that kind of coverage, you'd have to have something approaching iridium, like iridium with missiles. Just because, just give coverage over any place on Earth where you just might happen to see a balloon. Low Earth orbit satellites, they're also range limited. And that's why you need so many iridium, not iridium. So what's Tesla's satellite called? Yeah, iridium is one. The Tesla satellite, they're putting up thousands of these things.
Mhm.
Hey, Greg, how many more?
Many years ago, I worked a program where we had kinetic kill weapons on orbit.
Hmm.
And a fairly large constellation of those.
Wow.
Yeah, that was a pretty interesting program.
I'll bet.
You said had as in past tense.
Well, I worked at that, geez, that would have been 85, 90 timeframe.
Was that Brilliant Pebbles or something else?
Well, I don't know if it was part of Brilliant Pebbles or not. We had an R&D program at Lear Sigler when I was there as an engineer.
Okay.
Hey, Greg, do you mind speculating a bit about that synthetic radar we understand was on that package of what they retrieved from that balloon?
Well, synthetic aperture radar, well, that's
Yes.
capable of looking to the side, basically. And,
Oh.
that's one of the reasons you would like to go over with a balloon instead of a satellite, is you could do that. You really can't do that with a satellite, but having a side looking radar is a lot more practical at lower altitude. So they could get a whole lot more intel than they ever could from a satellite from a balloon. So as an intel package, a balloon is great, especially at that loiter altitude they had it at, where the winds are lower. So, we just let that thing give all the intel they wanted all the way across the country. And then we acted like, hey, we're tough, we'll shoot it down. No.
Greg, how many more
Gave
slides?
them free lunch. Huh?
How many more slides do you have?
Oh, that's pretty much, I got a few. That's pretty much it. So
Okay, no, I just want to
that's it. That is it.
make
That
sure
is
we
it.
can, we don't lose anybody here while we're asking.
So that's it. We've been through all the slides.
Okay, well, let me just say real quickly, I thought that was terrific.
Yep.
So did I.
I'll let everybody else talk.
I agree.
So,
Excellent.
I was blown away, literally, pun intended.
I said this.
I also, you went into so much more detail than I've ever heard. I remember Vice Admiral Monroe had a talk with Peter and I when, and you might remember it was 2010, 2011, I think, when we had something that appeared to be missiles that went kind of close to the coast of the east, west, and west coast and the Gulf. And the missiles, or what appeared to be missiles, went into the water, toward the ocean or toward the water as opposed to toward land. And Vice Admiral Monroe was absolutely convinced that these were missiles and it was some sort of a test run.
Could have been.
And he brought up balloons at the time. And I thought it was kind of an odd thing to bring up. I was interested in what he had to say. He didn't go anywhere near into the depth that you did. But is it possible that there were balloons involved in that?
Could have been. The thing is, the balloon's an easy platform to launch from once you master it. And we did that. I did that 25 years ago. And it was a small outfit. We weren't, was a club originally, then a very tiny little company. We ran out of a couple garages and we did a lot of phenomenal things. I want to show you something. Remember showing you that rocket? This is one of the motors, one of our test motors for that rocket that was on the back of the ship. This is the solid fuel grain. Now this actually has hydroxyl terminated polybutane in it, the same fuel as in military rockets, except they don't have ammonium perchlorate in it. The oxidizers are separate, so it's not explosive. That's why we had it as a hybrid rocket. This thing was actually burned for about 3 seconds. So that is a charred fuel grain. And if you sniff it, you can tell. This is the daddy of the Spaceship One and granddaddy of the Spaceship Two rocket. Yeah, it
Wow.
smells like it's been burnt a little bit, burnt rubber. That's what it is. So now I use that rocket motor as the table stand for my little laptop here. Don't everybody use rocket motors for table stands?
Greg, I was a little concerned that this would be too detailed and complicated, but it was spot on. I think we need to find a way to get you in front of some other people.
I'm
Uh,
ready.
sure.
Put me in front of the Senate, put me in front of Fox News, wherever you want to send me, I'll go. I'll even put my hair up in the ponytail and put on a suit. So I won't look quite as hippie or
got it.
hillbilly
Still
or mountain man or whatever you want to call me. Santa Claus. I'm Santa Claus, actually.
You look fine like you
See? Ho, ho, ho.
So, Greg, just a quick question here about the fabric and the materials in the fabrics. My experience in the microwave engineering has been that many polymers, especially up at Q band and the like, have very distinct properties that might make it visible to radars.
Yeah, so what you'd want to do is design some that radar wouldn't see. Most of these balloons are polyethylene for the balloon material, the plastic. But polyurethane has been recommended with carbon black and little iron filings to use as a radar absorptive material. So there's a lot of possibilities. We got some.
So Dave, the Q band, is that a different band than most of our military radar operates in today?
Yeah, it's way above. There are only some advanced radars that are working up at those frequencies. There's some presidential communications and that sort of thing too. The traveling wave tubes and devices that operate at those frequencies are real expensive.
Yeah, and would they not work at low altitudes because of the atmosphere would absorb the signal, or are they in one of those special frequencies that?
That's a really good question, and I don't know the answer, Rick.
Okay. Another dumb question, Greg. Could we pre-position balloons on a string ready to
Yeah, that's kind of what I was talking about when I said aerostats. We have aerostats. You're kind of limited by the weight of the tether itself. You'd want to use maybe some kind of Kevlar tether so it's got high strength and low weight, because it will hold the balloon against the wind.
Oh yeah,
flying free. So so it's got to have some strength, because the balloon's a sail, and so you get a lot of pressure on that balloon because the sails move boats, and so it's got to be a very strong tether. So there's a limit how high those things can go. I think some aerostats might be up to 10,000 feet. I don't know if anything that's got to get down to altitudes we're talking about, but it might be that you'd have an aerostat that could be designed. It could go higher, and maybe you'd cut it off if there's a threat, so it could get higher and do a job. It might be good if you took like some of these solar planes that NASA was playing around with and they got some of those up to great altitude. One of these, get it up and have it fly a pattern. I could pretty much come up with a balloon concept for that too. I called it this. I had an idea for a balloon that worked like a parafoil, and that would be flyable in a pattern. So it would be a parafoil type airship. So if you had something you could fly in a pattern that that you could fire a laser up to that could redirect it downrange, or it could be maybe have an onboard laser. So you save a lot of weight if you can just have some kind of mirror that redirects it. But then again, you got to get that laser from the ground station up. So you get some beam spread, some loss going straight up, but it's a lot less than going diagonally across. So it will be more effective than, like I say, than going diagonally through the atmosphere.
I can't imagine a control system so stable that it could make the mirror hit the target. I mean,
that would be a challenge. It would have to be a dynamic mirror, very dynamic mirror, one of these flexible mirrors. They've talked about those kind of mirrors in the in Strategic Defense Initiative office.
Developing AI now, so it's gonna have to be something that involves artificial intelligence.
Could do it. So it might be the artificial intelligence would have a feedback system just to monitor the coherence of the beam that's coming out of the mirror and the direction the beam is going.
Yeah.
So the mirror would have a lot of little adjustable subsurface areas, and you might probably have a couple of mirrors involved, one to capture the beam and the other a redirect mirror. It might take a few mirrors to pull all that off to get it from going down here to going out wherever you want it, and then to make sure that the beam was heading where you want it and coherent at the same time.
So how do we get you in front of General Dynamics?
Schedule me. I'll talk to them. So I also set the appointment, I'll talk.
I think.
Hey,
it's
Greg,
a
Greg,
lot
this is,
for that.
hey, Greg, this is Glenn. I was, what's the operational ceiling of a, yeah, what's the operational ceiling of a, like an SR 71? Isn't that 90,000 feet or something? You remember?
I don't think it was 90. I think it was more like 70 something. Let me,
Okay, so assuming you could,
I can pull
you could
that up. Let me look for that.
yeah, so assuming you get up that high, the problem is going to be the weight of a laser put on a high altitude, extremely high altitude reconnaissance vehicle right now, which I aren't those chemical lasers that are capable of destroying what you're talking about? Aren't they extremely heavy?
Yeah, a lot of them used to be.
A chemical laser wouldn't fit on an SR 71, I don't think, would it?
Well, the problem like a SR 71, it's built to do its mission, which is reconnaissance. It didn't really have any external package. All right, it flew to 82,000 feet, says the operational ceiling.
Okay.
Specs were for 95, but I don't know if they ever flew that. Yeah, so that thing was an extreme high altitude craft.
Hey, Greg, there's a question in the chat room. What is the general fail rate of a balloon after launch? If it's high enough and
Very low, very low, very low. Most of them are going to fly. I don't know exact rate on that. I've flown a lot of other people flying. Of course, it depends on the experience of the crew and stuff like that. Now we will get some failures. I have seen one balloon where the manufacturer didn't get the top knot, which is basically a spool all the gores are fed into and held with basically like radiator clamps inside. It wasn't tightened properly or something. The whole thing just let go after the balloon was inflated. Fell right down on the deck of the boat. We were trying to launch a experiment for the JPL actually from a boat, and that was a balloon failure in that case. So yeah, but so for the SR-71 operational ceiling was 82, but the spec said it had operational ceiling of 91. Yeah, that's 95. That's crazy. I've never seen an aircraft do that.
Weren't those SR-71s retired?
Yeah, they are.
Yeah, NASA's still flying U-2s.
U-2s. That's what NASA's got, U-2s. And there's, talk about some other aircraft out there, or Aurora or whatever it might be that might still be operational and secretive. I don't know. But, where there was no attach points on the SR-71 to hang a weapon system. If you had it, it probably wouldn't get that altitude. So,
Hey, Greg, I was gonna ask Cynthia and Len for their comments on disseminating this thing. I'm Al Flores called me up and he was kind of in a panic after he looked at the slides and he goes, I don't think we should be sending this out to very many people. And I want to have a little healthy discussion on that because I'm a little bit concerned about that too. So thoughts? Discussion?
Well, my thought, well, I don't think there's any problem distributing the summary report to the general public. I would suggest we probably take our names off of that, just to avoid Greg's presentation is outstanding, but I think that needs to be limited to people that have some need to hear it. That could be, Congress, it could be, there's a variety of people, but they're not the general population.
Yeah. How about you, Cynthia? Got any thoughts on that?
I used to know Scott Perry pretty well, Congressman Perry, who's now in charge of the Freedom Caucus. He's a general. He was anyway, a National Guard. I think he would be probably the most appreciative of getting this kind of information. And I still know some of his staffers, so I can send that to him and see. I know they're awful busy at the moment with everything else that's going on, so I don't know to what extent you'll get a quick response or anything. But Scott Perry is probably the best person I can think of at the moment.
Well, that'd be good to get some feedback from that. The other thing, Cynthia, that I heard, well, no, I didn't hear, I read it. And that is, there's some stuff in the new debt ceiling rise that directly are are written for the power grid. So I know that Len knows about this, and it's stuff from Peterson, Michigan, and Hickenlooper from Colorado. I don't know what it means. It sounds like it's got RTOs involved in it, and maybe they're trying to get Texas ERCOT to be part
Yeah,
of an
what they were doing, or what they were suggesting, is to make the exchange of power between electrical regions in the country somewhat more seamless. In other words, east to west, north to south, and all that. And of course, we've got some general problems with that, and that east to west,
Yeah.
with the Rocky Mountains there, which have limited us transferring power from east to west for a long time. And ERCOT's its own entity down in Texas, and they had some other reasons, probably political, for doing that, and I don't know if they're going to change their mind about that or not. So that's what it was. But even in the Eastern Interconnection, there are a lot of barriers to transferring power. There are some traditional tight spots on the grid that have been around for decades, and no one's been able to solve them. AP South interface and PJM is an example of that. So that's what it was.
If I might add to the discussion, I don't think I've presented anything that hadn't occurred to the Chinese here, because they've already got quite a balloon operation. You can already see they're putting drop vehicles on balloons. That was a zero pressure balloon that had the drop vehicle. So they do super pressure, zero pressure. They got cargo ships. They've launched missiles with cargo ships. So this whole scenario has to be something that's already crossed their mind multiple times, especially if they got a balloon force that's like a branch of their military that's kind of under wraps, and ability to launch thousands of balloons. This has got to be something that is not new to them, because this is too easily done. Some of the original Raccoon missions were done by none other than James Van Allen back in the 1950s, before they flew the Explorer 1 satellite, because he was trying to get stuff up there to detect what the plasma atmosphere was, and at the outer reaches of space, or at least the closest they could get back then. So the Raccoon was his advantage, and they launched that from naval ships. So this is not a new concept to launch a Raccoon from a ship. I did have the privilege of talking to James Van Allen. Now, he was always, I'm a big fan of manned space flight, and he didn't like manned space flight, but we had an intersection that we both did Raccoons. I did get the chance to talk to him once, and now it was a nice conversation. So I'm glad I got a chance to talk to James Van Allen before he passed away. The largest geophysical feature of the planet Earth is a magnetosphere and a radiation belts he discovered. So he was quite the scientist.
I'm wondering if we should schedule Greg for an online seminar of some sort and invite the appropriate people. And they could be people like Ron Johnson's staff, Mike Gallagher, who's the head of the military, I forget the subcommittee in the House, and people like that. And they probably wouldn't attend, but their staff would, and that would probably be good enough.
Yeah, the staffers do the work. So if we can get some of these staffers, if we could accidentally get a few Congress critters, that would be great. But I used to run. I was the chairman of the policy committee of the National Space Society for 10 years. I ran the halls of Congress up one side and then on occasion when I talked to a congressman or a senator, but it's usually the staffers. And I've had the most impact talking to staffers, actually, in terms of getting things done. We've changed legislation. So I've had major impacts on some of the space architecture. I was selected when Senator Nelson was senator by getting to Paul Danfus, who was his main staffer at the time, Colonel
Hey,
Danfus.
Greg, can I ask you one more technical question? Do you figure that this was either a satellite or a terrestrial communication back to China? How did they transport the information back?
Probably satellite. I mean, what I had outlaid in this presentation was how you could use iridium basically to communicate with this package.
Yeah, I was just going to say iridium.
Yeah, iridium is just easy to do. So yeah, it was probably
iridium is satellite?
Yeah, but now think about this. There's so many Chinese people in the United States. Who knows? They might have had ground operators all along the path.
Oh yeah, oh yeah.
So many Chinese here. Holy smoke, gosh, who knows what they got here right here in the United States domestic.
I'm betting they have a platoon of their soldiers here already.
Yeah,
It may be, well, I would bet they got some sleeper cells organized. I mean, you think about this.
Oh, yeah.
They had the Reigning Revolutionary Guard say, what, 15, 20 years ago when that first report came out saying that 9 substations, all it would take to take down a power grid, and one of the staffers ran to him all excited. Hey, look, what we got to do is take out 9 of them. He just kind of rebuffed him and says, I already got sleeper cells in America. We've already got 20 of them targeted.
I doubled down on that.
yeah.
Well, I had extensive talks with Peter about that number 9, and he asked me to do some research on that, analytical. And I think 9 is a little bit too optimistic. I came up with 3 just to take down the state of Texas. So that only leaves 6 for the rest of the country. I think it's probably a little lower. Closer to 20 is probably the right number.
Well, they got 20 targeted some umpteen up years ago, and Lord knows our border has been so tight. Nobody could get in to bring any more sleeper cells in this country. No.
Greg, let me ask you about the Chinese electronics. Any idea if their chips are rad hard?
I'm sure they have some rad hard. You know, it's easier to make the rad hard ones than the little bitty ones. But to make little bitty ones rad hard, yeah, they're not there. If they got real high density packed, if they're up there, you know, they're not up there with the Taiwan Semiconductor Manufacturing Corporation in terms of what they can build, what their top end manufacturing buildings are not there. But I assume they got some red hard chips. You know, we've had red hard chips for a long time, but it's how much sophistication do you put in it? And we had red hard. If you look at the flight computer, the Saturn V, it had some of the very first integrated circuits that's actually used in anything. And
Oh, yeah, that was TTL. That's radiation hard.
transistor logic, true.
It's the CMOS that's the issue. There was an IBM outfit in Manassas that made a rad hard computer with I think it was silicon on sapphire processor. It was pretty nifty, quite expensive. So I'm just I'm wondering if that's a susceptibility maybe and a way to attack the electronics.
Well, if you want to attack it with an EMP, that if the electronics are critical to firing the circuits, but like I said, if I were doing that, I would anticipate that from the get-go, and I would just make the whole thing initiated with a washing machine timer. Just dial it up. And once it winds down, it makes the contact and things happen. And it might just be a cut down. I mean, the best way for them is that if the thing drops, if you shoot it down, it goes off. So just put an accelerometer switch in it. And the accelerometer could be inside the warhead, fairly well protected. Although the accelerometer would by itself might be susceptible. So yeah, and they could have a couple of different circuit paths to fire it. You know, they could have some redundant logic, especially if they employ a few AND gates or something like that. But you know, redundant logic and maybe non-electronic. Like I said, it could just be a wind-up timer. It might be the whole thing. So yeah, they can make it where it's hard to defeat. I think the key to beating this is 1, to have the awareness, 2, to be able to field a system early on. Don't wait till it's overhead because it's already within EMP range of you and can do a lot of damage. I mean, it don't have to be overhead. It can still be way out at shore and do extensive damage on your coastal facilities. That's the whole point of this presentation. That's the message I'm bringing that's unique and different from what anybody else has brought to the table here, is that these things can hit us. They can hit us hard. They can hit us hard from offshore. So you got to be able to identify them and deal with them early. We want to do a proper identification. We don't want to be taking down invalid targets and wasting our rounds on party balloons. But I've already gave you a size spec here. If in most other balloons, you know, these sizes are going to follow NOTAMs, and notice with airmen and stuff like that, there in the United States, you're going to know there's been a filing somewhere that this balloon's aloft, and some of them have tracking. The bigger ones have tracking devices on them. So you know, there's plenty to go by to distinguish whether it's a threat or not. I don't want to put any more regulations on the scientific ballooning community. I want the people that want to shoot them down to understand what parameters they're going for. if these things are coming from out over the ocean, we never saw them before, they're probably, even if we're, just coming up from offshore, they're not ours. There's several things we can take into account like that, into the logic for do we shoot it or not. And it shouldn't have to take a long time to figure that out. It should be very fast. Because if you're sitting around going, no, what do we want to do about it? It's gaining altitude every minute you got your thumb where it don't belong. If you're, so this is going to take some really good detection, some good smarts, and a system that can get something out there fast, whether it's a laser dither from altitude, whether it's a rocket from altitude, or you got some other something that can reach the altitude at lower cost than an Aegis missile system. That's an expensive missile. And we may, China's already practiced taking out our aircraft carrier groups by dropping DF-17s and stuff like that, the hypersonic missiles. And they claim that in 3 waves, they can take out an entire carrier group because they'll saturate all the defenses. We'll use up all our Aegises, and they don't think our lasers that we're developing is going to do the job.
Hey,
So,
regarding that, let me just throw something out there for you. What do you think, Greg, of keeping a flight of reconnaissance aircraft airborne on a regular basis? I mean, continually airborne. There's Oklahoma Tinker Air Force Base is home to a newly developed reconnaissance aircraft. It's called the Air Tractor AT-402. It's a turboprop, and its approved altitude is 30,000 feet, and those things have all kinds of jamming gear on them. I mean, the state of the art in terms of EMP warfare. What do you think of having something like that on an ongoing basis as just like a patrol, just like somebody walking a beat? They're flying up there at 30,000 feet.
we need all the eyes we can get. Like I said, if they got a wind-up timer, the EMP device may not take it out if it's just a wind-up timer. But they're going to think about this ahead of them. That's why I showed you this idea of making it, if a balloon by itself is not metal, you used to fly metal. They used to put these radar reflectors on balloons so they could be spotted by radar. It's just a big metal cross structure that you'd put on to make them easier to spot by radar. So, that's one of the things that looks like they showed up in the Roswell crash. That was a balloon reflector, radar reflector. So whatever that was, at least whether it was a UFO or not, somebody pulled out a balloon radar deflector. I saw it in one of the photographs. I go, that's definitely a balloon radar reflector. Someone brought it in later or what, but it was a balloon radar.
Well, that's a mission that the National Reconnaissance Office might be interested in.
Yeah. But yeah, we definitely need recon aircraft. We need something at a higher altitude if we want to be able to actually engage the targets.
How easy is it to see this at 100,000 feet? I mean, we're not normally looking for stuff at that.
Well, that would be an easier target to launch something at them from. That would be the thing, is if you can get above most of the air, it would be easier to launch at them. It's like the AIM-9 may have a 20-mile range, but it's not going straight up. If it's going out, it would do better. Even that thin atmosphere, I don't know if an AIM-9 would probably drop like a rock, because there's not much hope. It's got some momentum, but it certainly is going to get much bite for gliding.
Well, and it's a projectile then. It's not it's not steerable.
Yeah, it's a projectile. Yeah, like I said, the burn time on that motor is only 5.2 to 6 seconds, depending on the version. They're short burn time motors. So it's not much better than a bullet, It's a projectile, exactly. So the AIM-9 is, you can't really count on it to get at the balloon at altitude. We got to come up with something. So it's going to require some thinking, but key to this is going to be early detection. And like I said, if you're watching from shore, you're not going to see it till it's 80,000 feet up. You don't want to wait that long. We need something out closer, out at sea, watching these, whether it's on a ship or it's on a plane at altitude. All these are possibilities. But we need better. The earlier you see these things, the better it is to deal with them. If you can catch them early on, you might and take them down while they're within fighter aircraft range, you're better off.
Yeah, that's the key, Greg, is early detection and actually deploying a solution, because
Early detection is the
we
biggest thing. Early
we
detection and
we
deployment.
we can early detect these things and then just watch it just float over. and
That
we're
would be a problem. Then you're in big trouble. No,
Well,
I'm for not taking out inappropriate targets, but I'm definitely for taking out the right thing and doing it fast.
Yeah,
You gotta do
yeah.
it before they get out.
Didn't we early detect the balloon the first weekend and?
Yeah,
Right. So guys,
before it
I hate-
got to Alaska, before
Yeah.
it got to
Yeah,
Alaska.
yeah.
Yeah.
exactly.
That's what they tell us. That's what they tell us.
well, guys, I hate to rain on everybody's parade, but we're at an hour and a half, and we probably should put a wraps on it in case. But we should have some closing comments and words. But let's try to wrap it up within 5 minutes right now.
You know what? I'm for releasing this thing as widely as we're comfortable at doing, because I don't really think there's anything in here the Chinese haven't thought of. Yeah, a terrorist group could do this kind of stuff too, but that's also something that's been discussed in the past. And there are groups that understand balloons and operate from the sea. It's not that hard to do. So,
Well, I know, but the problem is, Greg, as we know, we don't want to make it easy on them, because you've got everything you could ask for in one presentation. We want them.
I
to
think
do
they
it-
already know this.
we want them
gotta
to
wake
do a little bit
people
of
up.
work.
Definitely, we need to go the powers that be. We need to go the decision makers, whether in the military, Congress, the decision makers absolutely got to see this. The congressmen, the Homeland Security, the military committees, members of the military. Now, we could water this down for the public. You know, I could take out the
No, no.
device stuff and just.
I wouldn't worry about that. I think we release the summary report, we take the names off of it, just to protect people. And then this thing here, we get it to the people that need to know this stuff. And there's a lot of people that are in the right positions that probably don't know it.
No.
And if
My
we
name's John
decide-
Hancock. Leave my name on it.
if we decided to release the large report, I would suggest we do it in the way of a video, so Greg's words can go along with the slides, because you'd be missing a lot of it.
Well, you know, I got I got several YouTube channels. I could do this as a YouTube video.
Oh, that would be great.
Fantastic.
I could just present what I presented tonight on YouTube.
That would be wonderful.
If you want to send me to do that, I could put it on YouTube. I could put it on GMTGreg, just go right
Yeah,
through that.
why don't you do that, and then we'll put it on our YouTube channel too, Greg, if you don't mind.
Yeah, I can just read right through these same slides.
Hey, Greg, somebody wants you to do that. She's called Cynthia.
What?
Cynthia wants you to do that.
Yeah,
Oh.
take it.
She's the boss.
Take it to the okay.
No, I just think it would be, would behoove you, it would be a lot easier to convince the politicians. I've been working with politicians for so long, I'm pretty well disgusted with most of them, but they tend to ignore things that are on print and not ignore things that they can see and hear.
Well,
Oh,
and
I
that
think we did.
presentation was very compelling.
It was very, very compelling.
Yeah,
Agreed.
well, that's great.
Early
Well, guys,
detection.
I've got to go. You can chat a little bit more, but I'm taking off. Thanks, Cynthia, for being on, and Len for doing it, and of course, Greg and everybody else that
Well,
participated.
I'm gonna go too, so I'm gonna press the button here.
Well, it's kind of crazy. I got the intersection of having the balloon experience, rocket experience, electrical engineering. I've been on the policy committee of the National Space Society, run the halls of Congress. So, you know, it's kind of like I got these intersections of experience that all just, this paper was like what I had to do.
Greg,
Virgin Apex.
Exactly.
That's
you're the best, Greg. If you only played a guitar, you'd be at the top of my list.
I can't play guitar. Not yet. Maybe I'll learn one day.
All right, I'm gonna
Hey.
end this, but I think we're gonna try to figure out how to get you in front of the right people is the bottom line.
All right, I'll count on y'all for that. Yep, I will go talk to anybody you get me in front of.
I agree.
I don't mind news media. I'm not scared of a camera. I've been on I moderated a panel for an hour on C-SPAN once. So I've been on C-SPAN. I'm on the Weather Channel on something called Strange Earth. I did several episodes for that. I'm on TV. I've been, you know, and I've been cited by Fox News with Buzz Aldrin in some articles. I've been out there, so, you know, I'm not scared of it. So wherever you want to send me, I'll go.
Good.
It was terrific.
Good for you, Greg.
Excellent, Greg.
Use me to get the word out. Just if y'all can set it up, I'm there.
Yeah, okay.
Good.
So I'm gonna pull the plug here in 5, 4.
All right, bye, everybody.
3,
Bye
1.
now.
Adios.
Thanks, Greg.
Yo.